All right, 11.3 is on arithmetic sequences and series. So an arithmetic sequence is a sequence whose consecutive terms have a common difference. So for instance, let's say I have 1, 4, 7, 10, 13, and so on. Okay, what am I doing to get to every term? So you're adding 3, right? That's called the common difference. All right, it's kind of confusing because they call it the difference and not the sum. But basically, you're taking one of the terms and you're subtracting out the term before it. See how if I started with 4 and I subtract out the one before it, I get 3. That's how it's happening. All right, so that means your common difference D for A1, A2, A3, A4, A5, and so on is the same as A5 minus A4, or A4 minus A3, or A3 minus A2. Makes sense? It doesn't matter what term you start with, you're just subtracting out the term before it, and they should all be equal. So number 1, it says determine whether or not the sequence 7, 3, -1, -5, -9 is arithmetic. So arithmetic, that's the way you pronounce it, but it looks like arithmetic, right? Arithmetic. You're just adding something to each term. That's how you can remember if it's an arithmetic sequence or not. So what are you adding to each term in this case? -4, right? So that's your common difference. So D is -4 because each time you have -4, -4, and so on. So your answer is yes, D equals -4. All right, number 2, find a formula for the nth term of the arithmetic sequence whose common difference is 2 and whose first term is 7. Okay, so let's kind of write out some of these different terms. So if I start with 7, what would be your next term?
5.
I heard 5 and I heard 9. It is 9, yeah, because you're adding 2. And that's why I said it's weird that they call it the common difference, but it's because we're always taking the second term minus the first. All right, so 7, 9, 11, 13, 15. That's what your sequence is going to look like, right? Okay, so let's think about this. We need to somehow come up with a formula for the nth term. So let's say I start with the first term. So a sub n is equal to, I don't know why my thing doesn't write very well anymore. A sub n equals, if I start with my first term, and I'm trying to get to the nth term. So let's say I start with my first, and I'm trying to go to the first, second, third, fourth term. How many little common differences did I add? 3. I always call these swoops. I added 3 little swoop things, right? So if I'm trying to get to the if I'm trying to get to the 5th term, I add 4 swoops. So if I'm trying to get to the nth term, how many swoops do I add? N minus 1, right? You're adding n minus 1 of them. Okay, so if I'm starting at my first and I get to the second, you add 1 of those.
Wait, why do you do n minus 1?
Okay, if I'm trying to get to the first, or if I'm trying to get to the third and I start at the first, I add 2, right? So to get to the third term, I add 2 swoops. To get to the fourth term, I add 3. To get to the 5th term, I add 4. 6th term, I add 5. You're always adding 1 less, right?
Wait, so is that why you're adding
Yes,
one
that's why it's
less?
n minus 1. You're adding 1 less of the little swoop things. All right. So let's think about it. So if I have the nth term, my first was 7. I'm adding 2 n minus 1 times. So I have 7 plus 2n minus 2. So I get a sub n equals 2n plus 5. Okay, let's see if it works. So we're going to check in our head. If you find the first term, so you plug in 1 for n, what happens when you plug in 1? What number do you get? You plug in 1 here? 7. That's the first term. What happens when you plug in 2? 2 times 2 is 4, plus 5 is 9. Plug in 3. 6 plus 5 is 11. 4. Do you see how this pattern is working out? 4, 13, 5, 15. Is that the only formula? It's the only arithmetic formula. So there might be something really strange.
It could be 5 plus 2.
5 plus what? 5 plus 2n, same thing, yeah. All right, next up. So that's your formula. All right, so we're going to use that formula. So we're going to say if I want the nth term, I start with my first and I add on n minus 1 of the common differences. Okay? It says where d is the common difference and a1 is the first term. So let's use that formula. So let's say I want to find the sixth term. So the sixth term, I would start with my first term and I would add on 5 common differences. Well, if I'm starting with 15, that's my first term, and 12 is my second, what's your common difference? D equals negative 3, right? Negative. All right, so it's A1 is 15 plus 5 times negative 3. So what's the sixth term? Yep, it's 0. And now you could easily find that. I mean, you could just keep subtracting 3 from here and find the sixth term. But on your test, I'll ask you things like find the 1001st term, and you don't want to have to do that, right? You want to know this formula. I will say last year I asked like something about the 50th term, and I had someone that wrote down every single term until they got to the 50th. And then later on today, we're going to learn that there's something called the partial sum. So you have to add all your 50 terms together.
Did they get it right?
I think they messed up somewhere, if I remember. I think they like messed up one of their numbers. So please don't do it that way. Please save yourself some time. All right, so find the 20th term of the arithmetic sequence that begins with a 2 and a 9. So you guys try this one. So you're starting with 2 and 9. So think about your first term, common difference, all that. So D is 2 in this case. You're adding 2. So that's why D is negative 3. Because you're getting the sixth term. So 6 minus 1 is 5. Yeah, Abby, did you get it?
I don't get why you have to. Because in the first one you did, you wanted
It's
to
not
find
the
the
n minus
sixth
1
term.
thing. Because we're finding the sixth term, so you're adding on 5 of those swoops.
Oh my gosh.
Okay, anybody get an answer? Yeah, what'd you get, Lisa? 135 is the correct answer. You guys getting there? All right, so if you have the 20th term, you're going to start with the first term, and I heard someone say 19. Add on 19 common differences. Those are those little swoop things. Your D is 7. You're adding 7 each time. So that's what goes in for D. Your first term was 2. So I have 2 plus 19 times 7. 19 times 7 is 133, so 2 plus 133. So I get 135. Great. Okay, so now the question is, what if you don't have the first term? Can you still do this formula? So let's try it on this next one. It says the fifth term is 190. And the 10th term is 115. Find the first term. All right, so when you have two different numbers in your sequence, find a way to relate those numbers. So think about it. If I'm starting with the fifth term and I'm trying to get to the 10th term, how many common differences would I add to get to the 10th? It is confusing because you see the n minus 1 from before, so let's kind of talk about this. So if I'm at the fifth, you don't have to write this. I have A6, A7, A8, A9, A10. So I'd go 1, 2, 3, 10, 4, 5. I'd go 5 different common differences. So you'd add on 5 common differences. Okay, what I always remember, do you guys see where I'm pointing? This 5 and this 5 add to be 10. Just like in that last formula, go back to your n. See how you have n minus 1 and then a 1? Add those together, what do you get? 1 plus n minus 1. What do you get? N. You get n. That makes the n there. That's how I always remember it. Okay, so I'm going to add on 5 common differences. My A10 was 115. My A5 is 190. That's going to allow me to solve for D, so I always need to know what the common difference is. Subtract the 190, you get negative 75. Divide by 5, you get D equals negative 15. Okay, now let's go with Emily and Abby over towards my desk. You guys use A10. And from Logan over towards the door, you guys are going to use A5. Doesn't matter what you use. You can write an equation that deals with your number that I just told you and A1. So come up with an equation.
Wait, what are we doing?
You guys are doing A10. A sub 10. And A1. Write an equation that relates A1 to A10. Okay, so how about Elle and Haley? What'd you guys get for your equation? You guys are stuck. All right. If you start with the first term, so that's a 1, how many swoops do you need to add? 9. So if you start with A1, you'd add on 9D to get to the 10th.
That's it?
Yep. Or if you start with the 5th, or if you start with the first and you're trying to get to the 5th, how many do you add on? 40. Make sense? Those are the 2 possible equations you could have. Okay, so now let's try to find A1. So I know A5 is 190. So I have 190 equals the first term, A1, plus 4 times negative 15. 4 times negative 15 is negative 60, so I'm going to add 60 to both sides. So you get 250 is equal to A1. That's your first term. If you use A10, do you think you get the same thing? Yeah, same thing. All right, so last time in class we talked about the Gauss method. Do you guys remember Gauss method? Gauss rhymes with mouse. Yeah, he's one that was a little troublemaker. Okay, so Gauss did 1 plus 100 made 101, 2 plus 99 made 101, 3 plus 98 made 101. And he said there were 100 numbers in that list. So if he was pairing all the numbers together, how many pairs were there? 50. So then he did 50 times 101 gives 50, 50. So 5,050. All right, that's the Gauss method. This actually works for any arithmetic sequence. So any sequence where you're always adding the same number to get to the next number. Okay, so it actually works for anyone. And it actually doesn't even matter if there's an odd number. I mean, if I had 99 terms, this would still work out. Yeah, even if there's an odd number. Yeah. So if I have S sub n, what did Gauss do? How many terms were there total? 100, and he divided them into pairs. So if I have n terms, I'm going to do n divided by 2, right? Then he multiplied by the first and the last term added together. So we're going to write a sub 1 plus a sub n. That's the Gauss method. So n over 2 times a1 plus a sub n. It's an n. Okay, we call the sum of the first n terms the nth partial sum, because it could go on forever. I mean, you could have an infinite sum. But we talk about the nth partial sum, like the 6th partial sum would be 6 numbers. All right, so number 1, find the 16th partial sum of the arithmetic sequence. So think about it. If I'm finding the 16th partial sum, S sub 16, I take my 16 numbers and I pair them. So 16 divided by 2. So there's 8 pairs. I take my first number and I add it to my 16th number. This is all fine and dandy, except what? It starts with 0. That's what A1 is. Don't know what the 16th term is. So what do I need to do? Yeah, find it. So need to find. So if that happens, if you're in the middle of the problem and you realize that you need to find the 16th term, that's okay. Just find it to the side. A sub 16, that's what we were just doing. If you start with the first term, how many common differences do you add? 15 common differences. What's your common difference in this case? 12. You're adding 12. So it's the first term, which is 0, plus 15 times 12. 15 times 12 is what? I think it's 180. So that's your 16th term. That's what goes in here. So you're going to have A1, which is 0, plus 180. So I have 8 times 180, which is 1440. So the 16th partial sum, so S sub 16, is 1440. So this wouldn't be too bad, you know, if you just found all of the terms, so found the first 16 terms and then added them together. But like I said, on your test, I might ask you for the 1001st partial sum, and you don't want to have to do that on your on your test. That'd be mean. All right, next up. So find the sum of all multiples of 4 from 4 to 404. So all multiples of 4, I'd have 4, 8, 12, 16, 20, right, all the way to 404. So I see the wheels spinning in some of your eyes right now. How many terms do you have? No? Close?
102.
Nope.
How was it 400?
Nope. 101, because this is the first, second, third. Do you see what's happening? 4 divided by 4, 8 divided by 4, 12 divided by 4. So if I'm getting to the 404 for my number, that's the 101st term. Make sense? No, you're stuck? So Isabel, as you see, if I have 4, 8, 12, 16, 20, that's the first, second, third, fourth, fifth. See how you're just dividing each number by 4 to get what term it is? See how it works out? All right. Yep, so you're finding the sum of the first 101 terms. So I do 101 divided by 2, and then I do my first term plus my last term. In this case, I actually know those. So I have 101 over 2 times 4 plus 404. So it's 101 divided by 2. I'm going to do this all without my calculator, so let's see if we can do it. I have a 2 on the bottom. I have a 408 on top. What happens here? They cancel and reduce, right? So 408 becomes 204. Now remember, Gauss was really smart. He said 100 times 204. I'm guessing he did this. I don't know if he really did or not. I don't know if he was that ahead of his time at 10. It's 204 times 100 plus 1. We're going to use the distributive property to do this in our head. So if I multiply 204 by 100, you get 20400, add on 2 zeros. 204 times 1 is 204. So add these together in your head. You get 20604. That's your answer. Yeah, without a calculator. All right. Must not have changed the names from last year, so Elle's boyfriend here, Grant, owns a car dealership. Oh. Are they not? Okay. So he spends $18,000 on advertising in the first year, and he wants to increase his advertising expenditures by $1,400 each year. How much will be spent on advertising for the first 9 years? Okay, so it probably wouldn't be bad to find all 9 terms and add them together. But let's go ahead and use this method that we've learned. So we're finding the sum of the first 9 years, so S9. That's going to be 9 divided by 2 times A1 plus A sub 9. So far we look pretty good. We have 9 over 2. A1, you started with $18,000, but then we run into a problem because we don't know A9. So that's when you stop and you go to the side and you say, okay, I need to find A9. So A sub 9 is the first term plus what? 8 common differences, right? So A1 was 18,000. You're adding on 1,400 8 times. So when you do that, what number do you get? That's how much he's increasing it each year. You see it right there. Because after the first year, he would have 1,400 more than 18,000. After the second year, he'd have it twice. After the third year, he'd have it 3 times. You see what I'm saying, Bella? Isabella? So then you'd add 1,400. So you'd get 2,800. Make sense?
Yeah.
Okay. So that's your common difference. Okay, what do you get? 29,200. All right, that's what your A sub 9 is. 29,200. All right, so you add those two together, and then times like 4.5, and you get a total amount of. It's a lot. I don't have my calculator back here. Someone help me out. Do you guys get that?
Oh wait, 212.
212,400.
Oh, you better stay with it.
Oh, I got
Okay.
I got
spending one of your
Do I need to get my calculator out? I don't have mine. 212,400. 212,400. All right. Okay. Makes sense? You guys think you're good on this section?
Investing, man.